Somewhere along the Nile River in 2400 BC, an Egyptian healer prepares water for a wounded soldier. He doesn't boil it, he doesn't add chemicals, he doesn't pass it through sand or cloth. He simply pours murky river water into a hammered copper vessel and waits through the night. By morning, the water is transformed, it smells clean, it tastes pure, and the healer trusts it with his patient's life. This wasn't magic, this wasn't folklore. The Smith Papyrus, one of the oldest medical documents ever discovered, written around 2400 BC, specifically describes using copper to sterilize drinking water and treat battlefield wounds. It was codified medical knowledge, carefully inscribed and passed down through generations of Egyptian physicians. And what those healers discovered 4,000 years ago connects directly to a piece of modern science that the water filtration industry would rather you never think too hard about. Part 1. The Ancient Record. The Egyptians weren't alone. Across the Mediterranean, the Greeks independently adopted the practice within centuries and expanded upon it significantly. Hippocrates, the physician whose oath still guides every doctor practicing today, wrote around 400 BC about copper compounds for treating wounds, leg ulcers, and pulmonary disease. But his most consequential contribution to this story is what Greek sailors began doing on their long, dangerous voyages across the Aegean Sea. Water stored in wooden barrels turned green and foul within days. It grew thick algae and bred bacteria that caused violent dysentery, killing sailors by the dozens. But water stored in copper containers stayed drinkable for weeks, sometimes months, even under the brutal Mediterranean sun. The Greeks had no concept of bacteria. They had no understanding of ions or electrochemical reactions. But they could observe the result with perfect clarity. Men who drank from copper vessels survived, and men who drank from wooden barrels died. The Romans took the principle further than any civilization before them, engineering it directly into their infrastructure on a massive scale. Roman engineers installed copper piping throughout their legendary aqueduct systems, the most advanced water distribution network the ancient world would ever build. Water flowing through copper pipes arrived at public baths, fountains, and private households measurably cleaner than water delivered through lead or clay alternatives. The Roman physician Pliny the Elder, writing in the 1st century AD, documented copper solutions for ear infections, mouth sores, intestinal parasites, and skin conditions that plagued both soldiers and civilians. Roman legions carried copper vessels on military campaigns stretching from Britain to Mesopotamia, relying on copper-treated water to prevent the waterborne diseases that historically killed more soldiers than enemy weapons ever did. Meanwhile, thousands of miles away on the other side of the world, the Aztec civilization, with zero contact with the Mediterranean, independently discovered the identical principle. They gargled with copper mixtures for sore throats. They infused ceremonial water with copper to prevent wound infection. They regarded copper as a material intimately connected to healing. Two great civilizations, an entire ocean between them, no communication whatsoever. The same discovery, that is not coincidence, that is fundamental chemistry, waiting patiently to be understood. Part 2. The Science. What is actually happening? In India, a tradition began that has continued completely unbroken to the present day. Hindus store holy water from the Ganges River in copper vessels called tamra jal, and they have maintained this practice faithfully for centuries. Researchers at the University of Southampton tested this ancient practice under controlled laboratory conditions. Their findings were remarkable. Water stored in copper vessels for just 16 hours showed a 97.7% reduction in harmful bacteria, including E. coli, salmonella, and the cholera-causing Vibrio cholerae. No manufactured filter, no chemical additives, no ultraviolet sterilization technology, a simple copper vessel, and 16 hours of patience. So what is actually happening at the molecular level? When copper comes into contact with water, it releases positively charged particles called cupric ions, carrying a 2+ electrical charge. These ions don't passively drift through the water. They actively penetrate the cell membranes of bacteria, disrupt their internal enzyme processes, interfere with their ability to reproduce, and ultimately destroy them. A landmark study published in the Journal of Health, Population, and Nutrition confirmed this. Copper vessel storage for 16 hours reduced total bacterial count by over 97%, with no filter, no chemical additives, and no energy input of any kind. Now here is where the science becomes genuinely extraordinary. When you combine copper with zinc in the presence of water, you create what electrochemists call a galvanic cell, named after the Italian scientist Luigi Galvani. Zinc sits significantly lower than copper on the electrochemical activity series, meaning it is far more reactive and far more eager to give up its electrons. When the two metals physically touch while submerged in water, zinc atoms spontaneously and continuously begin losing electrons to the copper. Those electrons flow steadily from the zinc surface to the copper surface, creating a small but persistent electrical current between the two metals. This current is nowhere near strong enough to feel with your fingers, but it is more than powerful enough to dramatically accelerate the water purification process. The zinc functions as the anode, sacrificing its atoms to the reaction. The copper functions as the cathode, receiving those electrons and channeling their energy. The dirty water functions as the electrolyte that completes the circuit. This is the exact same fundamental electrochemistry that powers every battery on Earth, from the tiny cell in your flashlight to the massive one under the hood of your car. But instead of generating electricity to power a device, this natural reaction generates a relentless cascade of charged ions that locate and destroy contaminants. The performance numbers compared to commercial alternatives are genuinely staggering. A copper-zinc alloy filter medium known in the professional water treatment industry as KDF, which stands for kinetic degradation fluxion, removes 99.9% of free chlorine from water on first contact. It electrochemically captures and permanently removes lead, mercury, chromium, arsenic, cadmium, iron, nickel, aluminum, and hydrogen sulfide through irreversible bonding to the metal surfaces. And it accomplishes something that no standard plastic cartridge filter can do. It actively kills bacteria, algae, and fungi on contact through the zinc oxide naturally produced as a byproduct of the ongoing galvanic reaction. A standard activated carbon filter, the type found inside Brita pitchers, camping pump filters, and refrigerator unit cartridge, costs between $20 and $80 per replacement. 6 years of a handful of copper and zinc granules, the same metals the Egyptians used 4,000 years ago, costs under $10 and delivers objectively superior performance across a lifespan 6 times longer. In 2008, the United States Environmental Protection Agency did something unprecedented in its history. It officially registered 275 distinct antimicrobial copper alloys as scientifically proven to kill harmful bacteria on direct contact. This was the first time the EPA had ever approved any solid surface material as a verified antimicrobial agent. Copper was that material. And decades before that, in 1968, NASA had already proven the underlying principle in the most extreme environment humans have ever engineered for. Scientists developing a water purifier for the Apollo lunar missions created a device that weighed 9 ounces, was the size of a cigarette pack, required minimal power, and needed no astronaut monitoring. It dispensed silver ions into the water supply and killed 100% of bacterial contamination, keeping human beings alive in the vacuum of space. A private company, Carefree Clearwater, later commercialized the technology using copper and silver electrodes to release ions that destroy bacteria and algae. Independent testing by NASA, state health departments, and universities confirmed the system eliminated E. E. coli, Pseudomonas, Legionella, Staphylococcus, Streptococcus, and Salmonella, including pathogens that resist even high concentrations of chlorine. The EPA confirmed the science. NASA proved the principle in space. Universities replicated the results. The history stretches back 4,400 years across every major civilization on Earth. Part 4. Why you've never heard of this. So if copper and zinc purify water better than most commercial filters, cost almost nothing, last for years, and are backed by the EPA, NASA, and 4 millennia of human experience, why is this not the standard? The global water purifier market is valued at $35 billion annually, projected to reach $63 billion by 2032. The corporations that dominate this market all depend on one business model: recurring purchases from captive customers. You buy the pitcher, then you buy the cartridge, then another and another, 3 to 6 times per year, every year, for the rest of your life. That is not a product. That is a subscription disguised as a physical object. Now consider the competing technology. A system that lasts 6 years without replacement, made from 2 metals anyone can buy at a hardware store for pocket change, requiring 0 electricity, 0 proprietary components, and 0 brand loyalty. You cannot patent copper. It has been in the ground for 4.5 billion years. You cannot patent zinc. You cannot build a $35 billion industry on something that costs $10 and lasts half a decade. So what happened? The industry didn't ban it. That would have been too obvious. Instead, it was quietly marginalized. Copper zinc filtration is classified by the EPA as pesticidal because it kills bacteria. The word sounds alarming. It simply describes the same mechanism that has kept water safe for 4,000 years. The American Water Works Association actively discourages copper zinc filtration for chlorinated municipal water systems, not because it fails, but because it strips chlorine so effectively that the outflow water is too clean for their regulatory frameworks. Read that carefully. They discourage it because the filtered water is too clean. Meanwhile, reverse osmosis systems, which waste 3 to 4 gallons of water for every single gallon they purify, are marketed as the gold standard. RO systems cost $200 to $600 for installation, require membrane replacements every 2 to 3 years at $50 to $100 each, strip water of beneficial minerals, and waste up to 80% of all water that enters the system. But they generate revenue, predictable, recurring, beautiful revenue that shareholders demand every quarter. Part 5. How to build it yourself. Here is exactly what to do with this knowledge. Go to any hardware store and purchase 14-gauge bare copper wire and a strip of zinc metal. Both will cost you under $5. Cut the copper wire to about 30 centimeters and the zinc strip to the same length. Twist them together firmly so they maintain full physical contact along their entire length. This direct metal-to-metal connection is critical for the galvanic reaction to occur. Place the twisted pair into any clean, non-reactive container, a water bottle, a pot, a jar. First, pour your collected water through a cloth or bandana to remove visible sediment. Then let the water sit with the copper-zinc pair for at least 4 hours. 8 hours is better. 16 hours is ideal. During this time, the galvanic reaction works silently. Ions release into the water. Bacteria are systematically destroyed, and heavy metals bond irreversibly to the metal surfaces. After the waiting period, pour the treated water through a simple carbon filter, a clean sock or cloth filled with crushed charcoal from your campfire. The copper zinc kills the biology. The charcoal catches the residual chemistry. Together, they form a two-stage system that rivals commercial filters costing 50 times more. An independent lab test by a backcountry hiker in Colorado compared this exact method against a 45-valve commercial pump filter. The copper zinc and charcoal system removed 98% of bacterial contamination. The commercial filter removed 99.5%. The difference was 1.5%, for a price difference of over 900%. For a permanent camp setup, purchase KDF 55 granules online. These are copper zinc alloy in granulated form, optimized for water treatment. Fill a 12-inch section of 2-inch PVC pipe with the granules, add activated charcoal on top, and attach cloth screens to each end. You now have a gravity-fed filter that purifies thousands of gallons over several years for $15 to $20 total. A comparable commercial gravity filter costs $80 to $300 and needs cartridge replacements every 6 to 12 months. One important caveat to state clearly, because accuracy matters: copper zinc filtration does not remove all organic chemicals, particularly pesticides, and is not effective alone against parasitic cysts like Giardia or Cryptosporidium. For those threats, combine it with boiling or a certified carbon element, but for its core applications: removing chlorine with 99.9% efficiency, capturing heavy metals, killing bacteria, controlling algae and fungi, and functioning in hot water where many plastic filters fail. There's almost nothing on the consumer market that performs better for the price. Closing. Consider the full arc of what we have covered. 4,400 years ago, Egyptian healers used copper to keep soldiers alive. Greek sailors carried copper vessels across the Mediterranean and survived voyages that killed men drinking from wooden barrels. Roman engineers ran copper pipelines across an empire and delivered cleaner water than medieval cities would manage for 1,000 years after Rome fell. The Aztecs arrived at the same conclusion on the other side of the world without any contact. Hindu traditions maintained copper water storage continuously for millennia and still practice it today. In 1984, a man named Don Heskett dipped a brass pen in chlorinated water and watched 4,000 years of chemistry prove itself in seconds. In 1968, NASA entrusted 2 metals to keep astronauts alive in the most hostile environment human beings had ever entered. In 2008, the EPA registered copper as the first solid-surface antimicrobial in the agency's history. The science is settled. The history is undeniable. The evidence spans every continent and 4,000 years of recorded human civilization. This knowledge didn't disappear because it failed. It faded into the background noise of a market that had no interest in a solution that couldn't be packaged, branded, and sold to you on a subscription. The Egyptians knew, the Greeks knew, the Romans knew, NASA knows, the water filter industry knows, and now so do you.